açıklayıp hep birlikte ödüllerin keyfine varacağız. Afiyet olsun efendim.
Of all the energy we use in Europe is spent on heating or cooling our buildings. This is 40% we can easily eliminate right away. We don't need to invent the wheel, that's already been done. We just need to develop it. An energy budget for this kind of house is between 0 and €400. Impressive, quite frankly. Someone took the lead and proved that this is not just theory, it can be done in practice. Now, the houses are here. It's possible to build a house with an extremely low consumption of energy using well-known building traditions. This is documented by the 10 passive houses built by Isovir in Denmark in 2008-2009. Houses are structurally quite different, but no matter if you build a light or a heavyweight construction, you can be energy efficient. But what's it take? First of all, good insulation, no thermal bridges, an airtight envelope, energy efficient windows, and ventilation with heat recovery. The house retains the heat, so to speak. It uses the heat from the sun and the heat generated by the occupants and their electrical appliances. From the roof down to the foundation, a fully insulated, airtight envelope guarantees heat insulation. Fresh air intake and heat distribution are managed via a ventilation system with heat recovery. Just like a thermos, the better you retain the heat, the less energy you need to generate new heat. This thermography shows that a coffee maker takes a lot of energy to keep the coffee hot, unlike the thermos. The house has to be built envelope leaks, but the construction methods are basically the same ones we're accustomed to using. Extremely important. We need a very low linear transmission loss. For this house, 380 millimeters of insulation was chosen for the cavity between the inner and outer leaf. Inside the house, 550 millimeters of insulation is installed in the floor itself. By placing the floor insulation 100 millimeters below the foundation insulation, your blinding concrete will go down to the inner leaf element when it's cast, making a fixed connection from the inner wall down into the foundation. This provides a strong insulation layer all the way out to the foundation. Let's see what this foundation looks like in the design. Foundation of lightweight concrete blocks is built on top of a base of lightweight concrete beads. Cavity is insulated with 380 millimeters of polystyrene. The slab on ground is insulated with a total of 550 millimeters of polystyrene, topped by 100 millimeters of concrete cast in situ.
Angående fundamenter på det her hus her, der har vi valgt en løsning.
A double leaf foundation, internal and external, with in
1, 2, 3, 4. Duyuyor musun? Tamam. Şeye geliyorum, kayıda geliyor mu? Kayıda geliyor mu? Deneme 1, 2, 3, 4. Ha? Tamam. Tamam o zaman sorun yok. Tamam.
being plywood rafters for the main structural elements of the house can be installed. The foundation of this house is not load-bearing. Seen from the outside, it consists of 150 millimeters of lightweight concrete blocks, 80 millimeters of polystyrene, 100 millimeters of lightweight concrete blocks, and another 100 millimeters of polystyrene. A radon and moisture barrier is placed over the slap-on ground, which consists of 440 millimeters of polystyrene with a concrete layer.
Her har man valgt at lave et fundament.
The foundation chosen for this house is made of standard thermo blocks. This is not enough for a passive house, which requires a lower linear transmission loss. This house is constructed with external facade insulation, where gypsum is applied directly to an insulation material suitable for the purpose. In addition, the facade insulation extends right down to the ground, thereby providing an unbroken layer of insulation from the facade into the ground. This way, the whole foundation is also insulated. As opposed to a traditional wooden house, we use a through-going I-beam construction. This gives us a very high wood percentage in our external walls. As we wanted to reduce the wood percentage to obtain a better U value for the walls, we came up with this solution, where we place a batten at the back edge and a batten at the front edge. We then connect the two battens using two thin plates and fill up with glass wool in between. This approach has enabled me to reduce wood percentage to 3% from 7.5% for a normal wood frame construction. This makes it easier to obtain the U values stated in the energy frame calculations made by the engineers. If I'm required to add 10 centimeters of insulation in the wall, we'll simply cut the plate 10 centimeters wider and fill in with more insulation. In this way, I'll still have a low wood percentage but a thicker wall. The external walls on this house consist of 290 millimeters of insulation clad on the outside with 15 millimeters of vapor permeable fiber gypsum, topped by an additional 120 millimeters of facade insulation and a 10 millimeter rendering. Internally, a climate membrane has been fitted together with 45 by 45 battens and with a filling of 45 millimeter insulation. The finish consists of 2 times 12.5 meter fiber gypsum. Today, it's extremely important to make a tight building structure. We must make a blower door test, that is a pressure test, on the house. And if we don't carefully install the vapor barrier, corner solutions, solutions at the sill and solutions at the roof, the house will fail the blower door test. In the old days, the vapor barrier was placed here, right between the plates. This meant that every time the electrician or plumber drilled a hole in the wall, he punctured the vapor barrier, which obviously we weren't too happy about. That's why modern vapor barriers are placed 45 millimeters to the inside, meaning that you have an extra layer, 45 millimeters, followed by the plate out here. This means the electrician can route all his conduits through this insulation duct without breaking the vapor barrier. A vapor barrier or intelligent climate membrane is used wherever there are joints and a line of butyl is applied. Afterwards the joint is squeezed together, so we have a joint that's both glued and squeezed together. It doesn't get any better than this. Here at the windows, the climate membrane goes all the way out. As a result, the window's placed out here. This makes it possible to make a good seal between the climate membrane and the window. Ducts and lead-ins through the building envelope are always the points where leaks occur. But when we do it this way, we lay the groundwork for establishing a sound, tight solution. Today, a whole range of products are on the market, such as sealing strips and joint strips, so the problems can certainly be solved. You only need to think carefully from day one, before you start building. The main concept with this house is to build a standard single-family house that we can sell again elsewhere. Also, we wanted the external wall structure to be as thin as possible, with as much unbroken insulation as possible.
Og med så meget ubrudt isolering som overhovedet muligt.
The main structure consists of plywood rafters, delivered in whole elements with columns and beams covering the full width of the house, in this case more than 10 meters.
Det i det her tilfælde over 10 meter.
The plywood rafters are spaced at 1.22 meter intervals, a modular dimension that matches the plywood plates. Plywood is fitted on the outside of the plywood rafters as a facade structure and as plywood rafter supports.
Og som afstivning af lamelspærene.
300 millimeters of glass wool are installed between the plywood rafters in this house. External cladding is plywood and 80 millimeters of facade insulation topped by a rendering layer. On the inside of the insulation is a climate membrane followed by 45 millimeters of insulated lath layer. Plywood and gypsum plates sit on the lath layer.
Der kan vi prøve at sammenligne med
Let's compare this to an ordinary house, which on the inside has a load-bearing concrete or brick wall, insulation and a brick wall on the outside. Since the inside wall bears the load of the roof, the outside